Hi guys, this is Daryl at Integro, and today we're going to show you the three major components of our supplemental greenhouse lighting system. So as an overview, we have our ADR controller. This is a microprocessor that will allow you to set the photo period, real-time micromole values, and the moles per day that your specific crop would look for. We always want to use sunlight primarily in the greenhouse and supplemental lighting to reach these values. So the microprocessor is sold separately because it's not necessary to be ran with the main sensor. The main sensor would go somewhere near the apex of the greenhouse, and in this cage I've got light hitting it, which represents sunlight. And we're going to raise and lower the values of the sunlight, and what's going to happen is that's going to tell a little controller in this panel board that it needs to open and close a lighting contactor. So this is a very typical lighting panel that you'd see in your greenhouse. All of your circuit breakers would be dedicated to your supplemental greenhouse lighting systems. And what happens is we have a low voltage panel controller. It requires our universal power supply mounted to the backboard, low voltage connections, and a solid state relay. This is all pre-wired. So as you can see, now that it's installed in here, that green category 6 cable is made up to a little coupler. And the line voltage comes from the uninterrupted power supply, or universal power supply that is, over to an unswitched circuit on the contactor. It's always got power. What happens is when the main sensor says we don't have enough sunlight conditions, it will close this lighting contactor and turn all the lights on. So let me show you how that's done. We're going to go ahead and lower the light levels right now using our ADR controller to watch it happen. So we're currently in a rest screen right now. I'll go ahead and initiate. And I have a sensor page, which is what we're looking at. Our DLI, that stands for daily lighting interval. Our logs, we can see daily, weekly, and monthly historical data logs of how much sunlight was there. And our help menus. The micromoles is currently reading in real time, 613 micromoles. Our thresholds are established at 370 micromoles to come on and 430 micromoles to go off. And then target DLI, that represents a value that crops need based on their 3 levels of quality. And in our greenhouse report, which we have as a handout or online, it will be linked to this video, you have minimum, good, and high quality moles per day values. And you can take a look at a gazania. 6 to 8 moles would give us a minimum, good would be 10 to 12, and 14 above would go to high value crop qualities. Okay? So spend a little time on this, it's a good report. But how it correlates to what we're talking about here is I can set in our values the target DLI. So we might just set here a 40 DLI crop, okay? And that means I want to see 40 moles at the canopy, whether it's from the sun or a combination of sun and supplemental lighting. The 2 thresholds are 370 on, 430 off, 560 on, 650 off. So a lot more sun has to hit this sensor to turn them on and off, and conversely 370 micromoles, a lot less sun is necessary to turn the lights on and off. Our photo period is adjusted in 5-minute or 15-minute intervals, so in this case we have it coming on at 6:30 a.m. and off at 8:30, giving us a total of 14 hours on our photo period. Now if I have a crop that has possibly only 10 or 12 hours of sunlight, we know we're going to get some supplemental lighting if I don't hit that 40 DLI value. If I do hit the 40 DLI value, the supplemental lights aren't going to come on for that photo period at all, no matter how much the conditions change. What matters is that the crop's seeing that DLI. So going back to our sensor, I have an off and an auto, so I can manually override an unlimited number of fixtures as long as the panel's servicing them. Okay, I'm going to go ahead and turn it off. This is time date stamped. You'll see that here. In our auto position, which is where it's going to be normally, right now it's looking for light levels at 370 micromoles or less. So let's go ahead and watch it in real time. If you look down here, you'll see me dim this. And as I dim it, our micromole values have fallen between, well, below the 370. Now, it would take a sustained condition of 5 minutes to turn these lights on because we don't want the lights oscillating on and off. If you really want to test this, you move it into a test mode and watch the timer start to count down. That'll take a 10-second test mode so you can trial it and see that the sensor is in fact turning the lights on and off. And here we go. So now that the lights are on, We know that we've reached a threshold that not enough sunlight's there. We got to have some help. What can we do to further increase our savings is add a sensor on the back of the fixtures. So we offer this on our 420 fixtures, and what this will do is if the conditions are such that the lights need to be on but I don't need 100% of the light output, the sensor on the back will raise and lower light output to meet crop DLI for half the energy. So not only are they energy efficient on their own, they can be reduced by another 50% if the conditions don't require full brighting. Alright, so back to our controller. We've got target DLI. We're looking for 40 DLI in this case. But I'm going to go ahead before we talk about that and show you what happens as the light levels go up. We want to go above 430 micromoles, and here we go. Okay, and again the 10-second timer will time down. And 4, 3, 2, 1, off. And that's what you want it to do. So we would take it out of test mode, leave it in auto, and it's going to do its thing. The other features are, as I said, setting the photo period, high and low thresholds, our logs. That'll go back a day, a week, or a month, so you can see what the photo period was for that time. And then a pretty extensive help menu. We describe everything in terms of the operation, the photo period, what micromoles thresholds values are, target DLI, and so on. Micromoles. All right. The other thing about these systems are we like to be able to interface this with our iPhones. That is internet and Ethernet and Wi-Fi connected. So here we have currently a value which is 320 micromoles, 330 micromoles. We're going to raise that up. We're at 1100. And we'll see the real values here too. Pretty close to synced, but 1166 to 1199, 30 moles per day, and a target DLI of 30. What I'm going to point out is this is really best designed to alert you if you've not met your moles per day values. So if 2 days go by and you've missed your moles per day values, then you're going to get an alert. If you disable it, you won't get it. But the idea is to let you know if there's any problems. You can certainly log on and have a look at what your project's doing. As these stand alone, incorporate with your existing computers, or they can network together so that this can be the main and then all downstream can be communicating to this one too. That gives them an identity, and you can separate them in terms of what their values are per ADR controller. So just to wrap it up, this is our ADR controller, this is our main sensor, and that inside here is our panel controller. And anything I can help you guys with in terms of layouts, we do offer some sample lighting layouts online. That includes how many fixtures to get how many moles per day. Visit integro.com and you can see that. So thank you for tuning in, and please get a hold of us if we can help you with any of your technical questions.